So now let's talk about the sizing of a battery and battery charger too. So again, saying, so battery, what is the functionality of the battery? So battery I am using, one is whenever the AC supply lost in the system, whenever the AC supply is lost in the system, then my battery has to cope up the required load for the system. I mean, if you recall our auxiliary system SLD, we are having two transformers and one DG set and a battery bank. And this battery bank is feeding the essential emergency loads like the relays, operating coils, or any other which are very, very essential and mandatory loads. So the battery must supply the DC power when the load exceeds the output of the battery charger. When the load exceeds the battery output of the battery charger, see the conditions. This is my battery charger, and this is the loads for my battery charger, and this is my battery. So this battery has, when should it operate? It should supply the DC power. It should supply the DC power when the output of the battery charger is interrupted, when the load exceeding the output of the battery charger, or when the AC supply itself is lost. In these three cases, my battery should operate. So to size, now I have to size the battery based on the number of loads connected to this. So before going into this load schedule, we have to classify the loads before attending to this. In the battery charger, this is very, very important. I already given you this in our when I'm discussing about auxiliary transformer. Again, I am repeating here that the load classification, we are having continuous loads, non-continuous loads, and momentary loads. Continuous loads, non-continuous loads, momentary loads. Continuous loads are like lights, operating coils, all these are the continuous loads which are continuously on this battery. Non-continuous loads may be due to the fire pumps or some motors or other things. Momentary loads, isolator, breaker operations. Now, in the battery, if you see, when I am talking about the battery, we are having two types of, you will see two types in this battery, like float charger, support the charger, float charger, boost charger. So what is this float charger and boost charger in the battery charger, and how it is influencing on the battery? See, my battery is, I am charging this battery, and when it required, it is discharging. This is the process of how it generally works, like our cell phone battery. Simple. So I have there are two types of chargers in the battery charger. One is a float charger, one is the boost charger. What is a float charger? In a simple, suppose this is my input power of 415 volts. This 415 volts input power is giving to my float cum boost charger battery charger. Float cum boost charger. This float cum boost charger will also at the same time, this will what it will do is it will deliver, if it's a good healthy condition, it will deliver 220 volts DC to the station load, as well as it also delivered 220 volts as a tickle charging to the battery. to the battery. Critical charging to the battery. So this is the how generally works if in the case of a float charging mode. And now suddenly the float charger, maybe the input was interrupted. Then the battery feeding the entire station load, and now battery charging was discharged from up to this level. So this is the only charging status of my battery. So now when the input supply was restored, then this float cum boost charger will activated on the boost mode, and it will delivered, and it will give 120 volts, nearly 10% of increase, 120 volts delivered to, sorry, if I'm talking about the 110 volts, then it is a 120. Otherwise, it could be nearly 240 volts or 240 volts maybe to the battery, and it will make fast charging mode, boost charging mode. And same level, it will deliver 220 volts to the station load. If you just look into this float cum boost charger in a in a brief way, like it is a switch, and there is a transformer which is transforming this 415 volts of AC, 415 volts AC to 220 volts AC. And this 220 volts AC is converting to DC with rectifier unit and filters to reduce any harmonics inside it. And then it is connecting to some diodes, and it's going to the station connection. And I'm having a switch like this for here. I'm talking about the circuit of this FCBCT. And this is a switch, and this is a coil here. And this is the battery. Whenever it required, whenever I required a battery, this will, if this energize, this will close. If this close, this will energize and it will plug to here. So battery will deliver the power to the station loads. In normal cases, it will open, so it will be away. So this power will go in this way. In the normal boost mode, in the normal floating mode also, this board will be go in this way, float mode. This operating coil will be closer, this will be closer. So this battery charger is delivering the supply to the battery as well as this to this one. In the boost operation, say this will giving the supply to the battery, and this coil is opened up. So the voltage of nearly 242 volts will flowing through these dropper diodes, and then these dropper diodes where the voltage is dropping from 240 to 220 volts, and this 220 volts is delivering to the station, which is generally required for my station. So this we will call as a dropper diode stream. Dropper diodes are generally used to drop the voltage at the boost mode, because this now in here the voltage which is coming is not 220 volts, 240 volts. This 242 volts required for battery, not for the station load. So to stop this, to drop that voltage, we require drop diodes here. So that's doing it. The purpose of dropper diodes is that. So this is the inside circuit of the FCBC. So I have to select what is the rating of the FCBC I required, and also I have to size the battery. Two things. So in the substations, generally widely used battery is the lead acid battery. So before going into the battery, before checking into the battery, as per we have to select. Suppose we got a data from the manufacturer that we are purchasing. These are the batteries available for us, like Amaron battery or Exide batteries, whatever it may be. So you have to look into some characteristics of that cell. You have to, if you want to select the cell, so you have to comply to the standard of IEEE 11814. 1184 will tells the cell characteristics or cell selection. Generally, the cell selection will be done with respect some factors. One factor is physical characteristics, like by checking its weight, dimension, everything. Other thing is the life of the battery. And third, life of the cell. And third one is the what is the frequent and depth of discharging cycles of that battery. Ambient temperature, which where the ambient temperature is increases, the life of the cell will decreases. Charging characteristics of the battery, any maintenance required or ventilation, seismic characteristics, cell orientation. So these are the general factors we will check when you're selecting the cell. If you are well with the cell selection, then you have to do the sizing of the battery. So now the sizing of the battery will start. So before starting the battery sizing, so we have to do the load classification, like continuous loads, momentary loads, and non-continuous loads. So when you are done with the load classification, then the next step follows is the preparation of a duty cycle. Preparation of a duty cycle, very important in the battery bank. So this totally depends upon the way you are predicting that battery may come in this stage. It's totally, you have to get the data from the O&M teams. Suppose if you are constructing substation, if you're already having a substation which are running in the if running from the last decades, take the information from the team when the battery at what time, at what loads generally added on the battery at some periodic of times, then you will get to know, oh, the battery is failing in these cases. So what are the loads can be expected at that time? So generally, in a normal way, when you are preparing the duty cycle, let's see, in my prediction, generally it depends upon how much time you require the battery. The preferred time is for substations, mostly all prefer 3 hours. If you want, you can take 5 hours also. For timing, I'm taking 3 hours. This is I'm drawing. I'm taking a scale in minutes. 130 minutes, 60 minutes, 90 minutes, 120 minutes, 150 minutes, 180 minutes. So sort of 3 hours. Fine. So now I am having a when the AC supply lost. Sorry, someone asking the question.
Yes, sir. Sir, so after the load schedule only, we can size the battery. Battery
Yes.
sizing can be done.
Yes.
But like load schedule changes till the last moment, right?
Yes.
In a project, load schedule is normally changing. Like it's sometimes increasing too much also when the compressors and these other things are added.
Hey, no. See, compressors will not work on the battery, right?
No.
See, those loads are
load.
yes, only emergency loads. Emergency loads, what? Only these relays. These are fixed for you, and the lights, which are also fixed, depends upon your area of the system. You are selecting some lights. Coming to the main one, so there you are placing some margin. If you feel the loads are coming, suppose for the auxiliary, now you said the compressors or pumps, we are adding this. These will come under the transformer sizing, not on this battery. Battery, we won't run the compressors, right? If you feel that as an essential load and emergency load for your project, suppose I feel the compressor is an emergency load which is required at all the time, then definitely you have to add that in the battery. So that already you will come in when you are doing a project only, you will come to know that what are the loads are essential, emergency, right? So the remaining which are coming at the later, these are the normal loads. These are the add-ons, not essential. That's what I feel.
Yes, sir. Absolutely correct.
Yes.
I didn't go that way.
Yeah. Fine. So, so it's less than 1 minute, team. So I'm stopping here. Please reconnect again, because